Sand, whether you use it for building sandcastles, telling time with an hourglass, or hydraulic fracturing, is pretty much the same just about anywhere you go. An uncountable number of tiny grains mixed together to form the same dunes and beaches. But why does sand almost always look the same? And how does so much of it end up at the beach? Well, much of the world's sand is made out of the same stuff, tiny crystals of the mineral quartz, which is made out of silicon and oxygen, the two most common elements in Earth's crust. And as you'll know if you've ever bitten through the crust of a sandwich that had sand in it, quartz grains are small and really tough. Here's why. Quartz crystals form within a cooling blob of molten granite rock, or magma, deep under the Earth's surface. As the magma cools, different minerals crystallize into solid rock at different temperatures, and quartz is one of the last minerals to form. It's forced to crystallize in the tiny spaces left in the now cooling rock, pretty much ensuring that it ends up in a specific size range. But being last has lasting advantages. Minerals that do form in the earlier, hotter conditions have weaker chemical structures and weather away more easily than quartz, kind of like how a relationship forged in the heat of passion might not be as stable as a deep bond developed over time. So as the weak, flash-in-the-pan minerals wear away, the unfaltering quartz grains are left to pop out of the rock as sand. And then it's only a matter of time, sometimes a very long time, before the quartz sand gets whisked away by streams and rivers and carried to the sea. There, at the mouth of a river, the fast-flowing water slows abruptly, and the well-rounded sand drops out. Larger rocks and pebbles were already left behind upstream, while smaller sediments like silt and clay continue to be swept along by the weakened current and are deposited further from the shore. Over thousands and thousands of years, the paths of rivers sweep up and down the coast, dropping off piles of sand to be spread by waves and currents into smooth, sandy beaches. Of course, not all beaches are purely quartz sand, and not all quartz sand ends up on beaches. But the fact that so many beaches and so many sands are the same is a testament to the chemistry of the most common components of the Earth's crust as they cool and crystallize, and to the physics of sediments slowly shifting and surging towards the sea. They are, quite literally, the sands of time.